I'm audible, guys. Okay. Okay, so lastly, we have seen 1.13. Now 1.14 is just a multiple choice question. So nothing much to explain in that. It is not a configuration task. Okay, it is a multiple choice question. You have to select the correct answers between the given checkbox. So we'll start with 1.15. 1.15 is extend connectivity to IaaS site. Extend IPv6 connectivity from HQ through the SP into the GEOSC VRF on the IaaS site according to these requirements. Set up global IPv6 addressing on the link between R11 and R3. On R11, assign this address 2001:2710:311::2 to gig 0/0 interface. On R3, assign this IP on gig 1 interface. Enable the existing IPv4 BGP session between R11 and R3 to also advertise IPv6 prefixes. Do not configure a standalone IPv6 BGP session between these two routers. Now, which configuration they are talking about? Just give me a second. Which neighborship they are talking about? So they are talking about, see, they want that the IPv6 connectivity from HQ should reach to IaaS. Okay, IaaS. This is IaaS site over here. Okay. So it should reach from HQ to IaaS site. Okay. And here is the connectivity. So here they want that these interfaces on R11 gig 0/0 and on R3 gig 1 interface should be configured with IPv6 addressing. Okay, and if you remember in 1.9 task, we have configured both of them as IPv4 neighbor. So they want that we should use the same IPv4 BGP neighbor session. Okay. Perform bidirectional route redistribution between the IPv6 EIGRP and BGP process on R11. Ensure that all current and future IPv6 prefixes advertised between R11 and R3 will be installed into the RIB of these routers, with the next hop address set to the proper global unicast address on their interconnection. Any policy that accomplishes this requirement must be applied in the inbound direction. So basically what they want, I'll show you the solution over here. So first of all, we'll go on R11 and assign IP address. Then we'll form neighborship. We will say address family IPv6. Under IPv6, I'll configure neighborship with IPv4 address. Activate the neighbor. Okay. Then redistribute EIGRP include connected under BGP. And then under EIGRP, I'll say redistribute BGP and I'll give the metric values. Okay. On R3, same thing. I'll assign the interface IP. Okay. Then BGP neighborship I'll form. Okay. Now they are saying that the next stop should be set to proper global unicast. Now what happens in IPv6 if you don't set the next stop, it will give you the next stop as a link local address. So to set the next stop, we are using a route map. We are saying route map IPv6 next stop permit 10 and set the IPv6 next stop to. So on R11, the next stop will be R3's IP address. And on R3, it will be R11's IP address. And where we are applying it in the neighbor under VGP. Neighbor R3 route map IPv6 NH in the in direction. Same on R3 over here. Understood? It is asked in the question. So when I'm reading the question, please concentrate. They are saying enable existing IPv4 BGP session between R11 and R3. The GEOSC VRF on R4 that extends the IPv6 connectivity from R4 to R30 on the IaaS site is separate VRF of FABD2 VRF. Any route leaking from FABD2 VRF into GEOSC VRF must be done on per side basis and only for those FABD2 sites that need connectivity in the by configuring R and R4 only ensure learning about the routes of IAS. The IAS site possibly learning about the routes on any other FABD2 site. So what they want? Only HQ can reach the IAS site. No other, neither DC, neither branch 1, branch 2, branch 3, branch 4. They should not have routes of IAS. And IAS should only have the IPv6 network of HQ. Use the minimum amount of command necessary to accomplish this requirement. Do not remove any existing configuration. If necessary, you are allowed to use an additional route target with the value of 10,03681. Verify that host 11 and 12 can ping this IP address located at the IAS site. It is permitted to modify one existing configuration command on one of the SP router to meet this requirement. Now this is something what route leaking. So for route leaking, what we are doing, we are going on R3 under FABD2. We are saying route target export 10,03681. And under IPv6 address family, we are saying import 10,414. And on R4, what we are doing? Under FABD2, we are saying import. So whatever we are exporting from here, we are importing it over here. Okay. And also we are importing it under IPv6 address family under GEOSC. Got it? So this is what we are doing. And in the exam on R4, the loopback address is configured as /31 in this way. So we need to configure it as /32 and we need to make it the router ID of LDP. Okay, so we will forcefully make it as a router ID for LDP devices, LDP neighbors, you can say. So I'll copy this on R4. On R3. Then on R11. Okay. Now if you go on any of the switch 101, suppose if I go and if I check over here, do show IPv6 route. Here you will see EIGRP external network 2000 db8:4:14:. Okay, this network is there. If I go on host 11 and if I try to ping this network 2001:db8:4:14:1, I am able to ping. This is the IP on R30. So in the exam, you will not have access of this R30 unless you complete the section 3. But in our EVNG lab, we are having access for it. So I'll show you. So in the exam, show IPv6 interface brief. You see over here, this is the IP. Sorry, this is the IP over here. Okay, which is being advertised, which needs to be reachable. Now, if you see over here, show IPv6 interface brief. Oh, sorry, show IPv6 route. You will see the routes of HQ. VLAN 2000, 2001, R11 and R12. All the addresses. Got it? You see over here, show IP BGP or show BGP VPN v4 unicast VPN v6 unicast all summary. You can say so IPv6 BGP. Neighbors. Okay, they are not forming neighbors. Okay, this is my neighbor. This is your task 1.15. Hope it's clear, guys. One point 16, enabling internet access for FABD2, enable highly available internet access for the FABD2 company network according to these requirements. On router 12, 23, 24, bring up IPv4 BGP peerings with the ISP. Make sure that a default route is received over these peerings. Which peering they are talking about? They're talking about these peerings. R12 with ISP, R23 with ISP, and R24 with ISP. These are the three BGP peerings we need to configure. On router 12 and 23, inject default route into OSPF if it presents in the routing table from a different routing source other than routing source than the OSPF version 2 process 1. On each router, this requirement must be completed using the minimum possible number of commands. So what they are saying, if you're getting a default route over here from any other routing protocol than OSPF, then redistribute it into OSPF. Okay. So for that, what we are doing, we are going on. Just give me a second. Okay, we are going on R12 and we are saying default information originate. Default information originate to get the default route information under OSPF. We are giving this command. Okay, on R23 also we are giving this same thing. Now this, why this is there, I'll explain you. Okay. Now this can be configured in two ways, either this or either we can give any distance command. So I'll explain you why we need this metric value. On R24, inject default route into OSPF if and only if it is learned from ISP over BGP. Now there are two conditions. First is it should come via ISP, we have to check, and second it should come via BGP. Okay, to accomplish this requirement, it is allowed to use a route map that reference both a prefix list and a tag. This requirement must be completed using the minimum possible number of commands. So for that, what we are doing on R24, we are creating a prefix list. We are saying prefix list NAT permit the default route. We are creating a route map that is saying NAT match IP address in the prefix list and match tag 4 times 9. Now why we are matching this? Because here, if you see the autonomous system of ISP is 4 times 9. Now, whenever ISP will advertise the default route to R24 over BGP, by default, it will send its autonomous system as a tag value. So it will send this as a tag value. Okay, this as a tag value. So what we are saying, match if it is a default route and match if it is coming from 1999 ISP, 4 times 9. And then default information originate, but first check the route map. Okay, so after checking the route map, you need to advertise the default information into OSPF. Router 12 may be used as an internet exit for the FABD2 company network only if neither R24 nor R23 nor R24 are advertising the default route in OSPF. This requirement must be accomplished exclusively in router OSPF mode on router 12 without changing the default parameters on R23 and 24. Now they want that this should be the last path, or this should be the last path that should be preferred. The best path that should be preferred to reach the ISP is either R24 or R23. Okay. So if suppose my R11 wants to go, this will be the shortest path. So it will go via this way, but this should not happen. So for that, what we are doing, we are going on R12 and we are saying default information originate and increasing the metric value. Either we can do it in this way, or we can say distance, I'll keep 19 or I'll keep 18. Okay, distance 18. Okay, so this will be not preferred then. This will be preferred as last. Okay, so both the ways will work. On router 12, 23 and 24, configure PAT and translate the entire FABD to internal network 10.0.0.0/8 to the router address on the link toward the ISP. Create a standard ACL named NAT for this purpose. Do not use NAT pools. Ensure that the internet connectivity of the FABD2 company network makes use of highly availability provided by R12, R23 and R24. Okay, so we need to create PAT over here. So what we are doing, okay, we are using the IP access list, NAT. So this configuration will be same on all the devices, these 3 points. Okay, just the interface will be changing. IP access list standard NAT, permit the complete 10.8 network. IP NAT inside, source list NAT, interface gig 0/0 overload on R12. On R23, this will be same. And the interface, the outside interface will change. Same on R24 also. Outside interface will change, and then we will give the inside and outside command. Interface gig 0/0, IP NAT outside, and interface range gig 0/1 to 3, and loopback 0 IP NAT inside. Got it? Same on the other devices. So I'll go on R12. R23. And R24. Do show IP route. If you see over here, okay. Now if you see, there is a default route learned via D star null 0. Now if you remember, I told you that we need some configuration, the metric configuration in 1.12 task we did yesterday. So this is what for which we were doing. So if you get this D star, okay, on R24, you need to go under the tunnel. You need to shut down the tunnel, wait for a few seconds. No shutdown. You have to do this. Once the tunnel will come up. Now if you check, might be the problem is ISP. Okay. Might be I'm not forming neighborship with ISP. Sometimes in our rack, the interfaces on the ISP are by default down. Okay, so due to which you are not forming neighbors. You will not have access in the exam for these cloud. See, these are administratively down. So this is something Eve issue. Okay, but whatever configuration if you will be doing, whatever I have given, that is fine. Okay, once I do this, and if I go on R24, now I should see the neighborship forming after few time. Okay, neighborship is up. Now if you check do show IP route is learned via OE2. So again, what I will do, shut down, and no shutdown. See, it is coming via BGP now. So it should come via BGP. The default route should come via BGP over here. Same on R23. If you check, do show IP route via BGP. On R12, do show IP route via BGP. Okay. So form the neighborship. Okay, let me clear the process. Do clear IPOSPF process. Okay. So yeah, so we have added the distance command over here. So yes, it will, yes, CCI. So it will learn, it will be getting learned via OSPF. Okay, it will not reach via BGP. So every traffic will now go how? If R11 wants to go somewhere, it will come to R12, then it will come over here, or it will go like this. Okay, so it will go via OSPF only, R23 and R24. Got it? Now for testing, what I'll do, I'll go on any of the branch 3. So this is my host 61. I'll say ping 8.8.8.8. Why it is showing me unreachable? Problem. There is no default route over here. So DM VPN. No shutdown. Do show DM VPN. So the problem might be with the devices. Sometimes even if you keep the devices idle, okay, they will not work. I'll just try to flap the interface and check if the tunnel comes up. Okay, new tunnel is formed. I just flap the interfaces. So sometimes if you keep the devices idle, okay, so the tunnel goes down, and due to which my ping was not working. Okay, so let me check now. Okay, now it is working. Now if you trace 8.8.8.8, it is going to the tunnel, the hub, and then it is exiting via R24. Okay, it is exiting via R24. Now, if you go on host 11 and if you ping 8.8.8.8 over here, then if you trace route from here, No, in the exam you don't need. So it can either go via R23 or R24. It can take either way. So it is going via R23. Now, if I make any of the link down, suppose if I make R24 link down, R24 is down. Now, if I go on VPC and if I trace, if I ping now, ping should work. First of all, it will take some time. Ping is working. Now, if I trace, now it will go via R23. See, it is exiting via R23. Okay. Now, if I make this link also down, now every traffic from branch or from HQ should go via R12. If I start the ping now, it will take some time to reflect. See, ping started. Now, if I trace, see, it is coming to, is exiting via R12. Got it? Any questions, anyone? No. So, as per the question, they say that you need to configure the means you need to configure the you need to check the ping and also configure pad that translate the entire FABD to internal network. So you need to just configure it. Okay, but ping you can check it. Ping you have to check. Sandesh, I already explained why we need that distance command. So here we completed our section 1 part. Okay. Now just give me 2 minutes. Now just give me 5 minutes, guys. We'll start with section 3. Okay, I'll take a 5 minutes break and we'll start with section 3. Just give me 5 minutes. Okay, guys, I'm back. Let us start with section 3. Screen must be visible. Enable CLI access to R30. So as I said, R30 will not be having the CLI access. So there is no direct console provided to the R30. Moreover, R30 does not accept any remote connections because its VTY lines are configured with transport input none. Using RESTconf enable remote access to R30 for all remote access protocols according to these requirements. You can use host 31 to access router 30 using the IP address 10.3.11.1. Just give me a second. Okay. So they say you can use host 31 to access router 30 using IP address 10.3.11.1. You can use any method of accessing RESTconf API on R30 from host 31, including curl, Python, and Postman. So we will be using Postman. You must change the input and output transport protocol on all configurable VTY lines. The input and output transport protocol value setting must be set to all. So here, these are the parameters that we need to use. Okay, I'll explain you where all these parameters will be useful. Okay, just give me a second. So on R30, they will be configured in this way. I mean, they will be pre-configured. The pre-configuration will be in this way. So you will not have access to the R30, but here I'm having the access of R30. So I'm showing you it will be transport input none. We have to make it all. So you will go on this host 31. This will be the host same as it is. You have to access this Postman. Once you start this Postman, you will see this first page. You have to create a request. Go to authorization. Type of authorization, select basic auth. Under username and password, admin. Okay. This is given in the question itself. Username and password for HTTP authentication is admin. Now go to headers. Now headers are also given over here. Headers are given over here. Content type and the value is application hyphen slash young hyphen data plus JSON. Okay. So key is content type, value is application slash young hyphen data plus JSON. So copy this. Then the next key is what? The next key is accept. Next key is accept, and the value is same. Okay. Then you have to enter the URL. Now, before entering the URL, you need to check one thing. Go under settings. Under this default settings, okay, you have to go under this default settings and make sure this SSL certification verification is turned off. You have to turn it off. Okay. Then URL. Make sure the method over here is get method to retrieve the information. The URL is also given in the question. This is the URL. So you don't have to memorize anything. HTTPS. Okay. So you cannot copy and paste in the Linux machine. You have to write it manually. 10.3. Sorry. 10. It is not 10. 10.3.11.1 / restconf / data. Just let me confirm. Cisco iOS XE. Now this is case sensitive. So if it is in capital, you have to give it in capital -native : native /line /VTY. We are retrieving the information of line VTY. Okay, so this is the URL. Once you have done this, send. Once you click on send and scroll down, you will get the output over here, whatever is configured on R30. So what you need to do? You need to just copy the complete output, whatever you get. So you might get something different over here. Okay, you might get, so see, I'm getting only 0 to 4. Okay, you might get something different over here. Okay, you might get 5 to 15 also. Like I'll show you. Let me configure line VTY 5 to 15. Transport input none. Okay, and I'll go and I'll say send again. Now you'll see I'm getting 1 to 0, multiple things now. You might get these things. Okay, so what you need to do, you need to copy the complete output, whatever you got, select copy, and then go to body tab, go to raw. You will get a blank page. Paste it over here. Control C and Control V will not work. Okay. Once you paste it over here, wherever you see none, 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 delete it, make it all. Make sure you don't delete any of the comma or inverted commas or double inverted commas or anything. You have to make sure that you only delete none. Okay. Make sure you have done this. Once you do this, now say patch. Now say patch and send. This means you are patching transport input all. So if you see do show run, now after this, you should get the access of R30. See, transport input all. In some cases, for some people, after doing this also, they did not got access of R30. Don't worry. What you need to do, let me just set a password. Line VTY 0 to 4. Now these all things will be pre-configured. You don't have to configure. Okay, so if you don't get access after doing this also of R30, don't worry. Go to LX terminal, telnet from here. Telnet R30 10.3.11.1. See, I got the access of R30. So some people got the access directly via console, or some people will get access from telnet. So don't worry about that. That is good enough. Got it? Now you have done for transport input. Now again go to this Postman under raw only. Now wherever you see input, you have to make it output. Please make sure you see input correctly and make it output. Do not delete anything else. All the output from all the input, you have to make it output. Do it one by one only. Don't try to do it. Then again patch and send. Now go on R30. And if you check now, I'm getting now transport input and output all. This is what your task 3.1 is. Simple. Got it, guys? Any questions in this? Okay, now let us start with 3.2. Now 3.2 is using guest shell and Python on R30. On R30, enable guest shell and create a Python script named ripdum.py in the guest shell according to these requirements. If an additional IP network is necessary to start guest shell, you are allowed to use addresses from the range 192.168.255.0. Mohammed, you don't have to do any configuration to run Postman on the router. If you don't have access to the router, how you will configure? So router will be pre-configured. You are allowed to use addresses from the range 192.168.255.0/24. This range must not be advertised in any routing protocol. The Python script must be saved under the name ripdum.py in the home directory of the guest shell user. The purpose of the script is to display the complete contents of all routing tables in non-default VRFs created on the router. The script must execute the show IP route VRF or show IPv6 route VRF command for every non-default VRF created on the router, depending on what address families are enabled in the VRF. The script must determine the list of created VRFs are enabled address families dynamically every time it is run using, for example, show VRF brief pipe include IPv. The script must not attempt to display the VRF routing table for an address family that is not enabled in the VRF. It must be possible to run the script using the guest shell run python ripdum.py command from privilege execution mode. Now this is a complicated thing. So what exactly they want? If you see, there are two VRFs. One is FabD2. Now it is not same like exam. On R30, there might be some different VRF, but there will be two VRF, FabD2 Geosk. One will be having IPv4 and one will be having both IPv4 and IPv6 address families. What basically they want, if I want to get show IP route for VRF FabD2, show IP route for VRF Geosk, show IPv6 route for VRF Geosk. So if I want the routing tables of all the VRF, I need to search it one by one. If I am having suppose 10 VRF and all are having both the address families enabled, then my work will be it will consume time. So to make this work faster, they came up with automation. Okay, so they came up with Python script. So first of all, to enable guest shell, we need some virtual port groups. So we'll first of all enable IOX. So to enable IOX, you need to go under configuration mode and you need to say IOX. Now it will take some time for the IOX to enabled. Server has been notified to start. Now interface virtual port group 0. We are assigning an IP address to it. We are enabling app hosting for guest shell. We are saying app virtual NIC gateway 1 virtual port group 0 guest interface 0. Guest IP address 192.168.255.2. Net mask is this. App default gateway 192.168.255.1 guest interface 0. Now this you need to memorize. This all things you need to memorize. Okay. After this, you need to enable guest shell. To enable guest shell, you need to give this command in the enable mode. I'll say enable guest shell. Now it will give me an error. Please wait for the complete. The process for the command is not responding or is otherwise unavailable. Unless my IOX services is started completely, I will not be able to enable guest shell. So I have to wait for 2 to 3 minutes for the IOX services to get enabled. Okay. Now this is the script that will be giving you the output that you desire. Okay. Now this is the script. If anyone knows programming, they will understand. If anyone doesn't know the programming, okay, they have to memorize this script. Now the indentation of the script is very important. Indentation in the sense these are in one line. This is inside this. This is inside if. The indentation is very important. And every single comma, every single bracket, every single space matters over here. Okay, so I'll copy this script. See, now IOX is ready. IOX is ready. Now what you need to do? You need to enable guest shell now. Now guest shell will also take 2-3 minutes to get enabled. So guys, you need to memorize this script for the exam. Okay. This is only the Python script in the full CCI exam. There is nothing else for Python in this exam. This is the 8 to 10 lines script only. Guest shell is successfully enabled. Now I will go under guest shell. So to go under guest shell, I need to say guest shell. Guest shell is nothing like it is like Linux like bash. If you see ls, nothing. Now here I have to say cat. Or I need to say vim. vi is an editor. Vi ripdump.py. I am creating a file named ripdump.py. Vi is an editor. Now to insert anything in this file, you cannot type randomly. You have to go in the insert mode. So to go in the insert mode, you have to press the alphabet I. I for insert. So I am now in the insert mode. Now I have copied the script. I'll copy it again. Now you cannot copy and paste. You have to write the script. Okay, so I have copied. Now to save the script, what you need to do? You need to press escape key. And after the escape key, you have to press :WQ. This thing. Escape, then :WQ and hit enter. Now you can check ls. Now I have ripdump.py. Now to see the content of the file, you need to say cat ripdump.py. Okay. Now come outside, exit, come outside to R30. Now run this script. Guest shell run python ripdump.py. See, I am getting the routing table of all the VRF, FABD2, GEOSC and GEOSC IPv6. Now, if I create, they have said if you create any routing table in the future also, it should give me automatically. VRF definition, suppose ABCD. RD value is 100. I'm just creating random. You don't have to create it. Address family IPv4. Okay. Now, if I run the script again, it should give me this ABCD also. See, it is giving me ABCD also. Now, if I create an VRF definition, suppose test, and I give RD value 200:11, I'll not enable any address family over here. And if I run the script now, it should not give me output of this because it doesn't have any address family. See, geosk is there, geosk IPv4, FAPD2, and ABCD. There is no test over here. Got it, guys? Hope this is clear. This is your task 3.2. 3.3 is again a multiple choice question. Okay, so you can just go through it. It is just a multiple choice question. So nothing much to explain in that. So you can just go through the 3.3. Now section 3 only has these three tasks. 3.1, 3.2 and 3.3 is your multiple choice question. So we have completed our section 1 and we have completed our section 3. Okay, just give me a second. Okay, so we have completed section 1, we have completed section 3. Now from tomorrow we will start with section 2. Okay guys, if anyone needs installation of EVNG, please do ping me. Okay. Okay guys, bye, take care and be safe.